Welcome to our classes. Today's topic is how to write duality of a linear programming problem. First question is that why is this duality? So we write duality, dual of a primal, just to carry out sensitivity analysis. Whatever decision variables are there, just to check that to if we bring some changes in the values of those variables, what impression, or you can say how do they behave, or what impact is there on their behavior. Keeping this in mind, meaning thereby to what extent a particular decision variable is sensitive to a change or change in its value. So here today we will not carry out in this sensitivity analysis. The topic is just writing dual from a primal. In LPP, linear programming problem, it is said that every primal has its dual and every dual has its primal. As I explained, that we do it just to carry out sensitivity analysis. Now, there are certain points in writing a dual of a primal. Those points, rather we can say as conditions, that we must keep in our mind. One, there are normally 5 points that I'll cover here as conditions. One, that is non-negativity condition. We need to ensure that every variable, decision variable, has to be non-negative. Means they have to be positive. This is number one. Number two, that we need to check in any LPP where it is mathematically formulated, mathematical model is available, the typical type of maximization, that function is given, constraints are expressed as linear relations in mathematical functions, and alternative solutions are also given. So what is desired here is that all maximization cases, problems of maximization, this is desired that they must be having inequalities of less than or equal to type. All minimization problems must be having inequalities of greater than or equal to type. This is condition number 2. Again, to make you the point more clear, all maximization problems must be having constraints, meaning their inequalities of less than or equal to type. All minimization problems must be having inequalities greater than or equal to type. Point number 3, that is there should be no free variable. Means obviously decision variables we are talking about, say x1, x2, they are designated as. So they must not be free, meaning thereby they should not be unrestricted. Whenever there is a case, then we will deal it with separately by taking an example. As in simplex method, in my previous video tutorials, I had made it very clear that how to deal with variables of unrestricted in sign. What we do is that we replace them with the difference of two other non-negative variables, where one is preferably greater than the other one, and then after, if the difference is negative or 0 or positive, then we don't mind, but we preferably replace them by the difference of two non-negative variables. Fourth one, say in a mixed problem, if inequality is not a desired one, that is, if the inequality is in opposite direction, say if it is a case of maximization, and one inequality is of greater than or equal to type, obviously it is not desired. So we need to convert it into less than or equal to type by multiplying -1 both sides so that the inequality get reversed. And the last point is equations. In mixed problems, normally in place of or along with inequalities, we often face find equations. So what we do? We normally we replace it by pair of opposite inequalities. We take the two forms, one of the same equation less than or equal to types, so that and then another one greater than or equal to type, and then further we convert whatever is desired into. So that's how these 5 points must be taken care of while writing dual of a primal. Again, to count them: first, non-negativity conditions must be satisfied. Second, maximization problem should be having inequality of less than or equal to type. Minimization problem greater than or equal to type. No free variable means unrestricted variables should not be there. Inequality in opposite direction is not desired, that must be converted. Equation should be replaced by pair of inequalities. These are the conditions to write dual of a primal. Now the question again, that how to write dual of a problem. So say that typically this is the primal, wherein we are accustomed to solving the problem where we normally have, say, maximum z is equal to cx, means the coefficients of decision variables, and some linear relationship. Those objective function is expressed as linear relationships. Here we will be taking up after a short while that problem. We know it that the problem is, say, for example, maximum z is equal to 8x1 plus 10x2. So here 8 or 10, that is the coefficient of decision variables x1 and x2, that is represented here c into x, subject to two constraints stc dots, you see written here in short, and ax, here a x, that is the decision variables, a the coefficients, and less than or equal to type, here the resources we indicate, like any inequality has, basically inequality is the mathematical represented as mathematical, a form of a mathematical linear relationship of the constraints of a particular problem. So right hand side we indicate by b, and x, that is the alternative solutions. So herein, well, c, here it is clearly explained that c is the row matrix containing the coefficients of objective function. X, c is a row matrix, keep in mind this in mind. X, that is column matrix written, that is containing decision variables. X, column matrix containing decision variables. Then we have A, matrix containing the coefficients of constraints. B, column matrix containing values of right hand side of the constraints. Now come to dual. So please watch it carefully, listen to me carefully, that from primal to dual, opposite of almost everything is written here. Like here, if it is maximization, so here it will be minimization. Say z, we represent it by, there is no logic, rather a different symbol had to be put in. So we are taking as capital G is equal to y. Y, here it was, y is column matrix of the dual variable, means the constraints x were the decision variables, and here it is when we write dual, so we represent it by y. Now b dash is basically transpose of b. What was the b? B was basically a column matrix containing values of RHS of constraints. So here we take it, we replace it by C actually. So B dash is transpose of B and subject to constraints. A, that was the matrix containing coefficients of coefficients of constraints. So here we take it A dash. A dash means transpose of A. Transpose of A means whatever is in column that is treated as row, or whatever is in row that is treated, row matrix is treated as column matrix, or column matrix is treated as row matrix. So I am not going to into the detail of matrix and all. I hope that each of you understands it well. So here Y, that is column matrix of the variables of dual, and C dash actually transpose of C, that was earlier row matrix. Now here it will become a column matrix. Row matrix, C was row matrix containing the coefficient of objective function. So now here it will become column matrix and Y greater than or equal to 0. So that's how we have understood very clearly that what are the conditions here, how to write a dual from primal by taking the transpose form of the different matrices, the arrangement. So इस तरीके से हम इसको अच्छे तरीके से समझ लेंगे. एक बार हम रिपीट करते हैं. फर्स्ट, नॉन नेगेटिव कंडीशंस मस्ट बी सेटिस्फाइड. दूसरा, मैक्सिमाइजेशन के लिए लेस देन और इक्वल टू, मिनिमाइजेशन ग्रेटर देन और इक्वल टू, नो फ्री वेरिएबल, इनइक्वालिटी इन अपोजिट डायरेक्शन डिजायर्ड नहीं है. इक्वेशन हम पेयर ऑफ इनइक्वालिटीज से रिप्लेस कर देते हैं. एंड दैट्स हाउ वी डू इट. नाउ लेट अस टेक अप एन एग्जांपल, a simple example, just to see by keeping this in mind that how do we do it. So here just I am leaving it to you so that it is in your knowledge and you are watching it, and so that you can, आप इसको देख सकते हैं. जो एक क्वेश्चन हम लेते हैं उससे कैसे हम कन्वर्ट करेंगे. मान लीजिए एक क्वेश्चन हमने लिया, मिनिमम z is equal to 10x1 plus 20x2, 10x1 plus 20x2 subject to constraints 3x1 plus 2x2, 3x1 plus 2x2 is greater than or equal to 18, x1 plus 3x2 is greater than or equal to 8, and we have 2x1 minus x2 is less than or equal to 6, x1 x2 greater than or equal to 0. Say that this is the primal. हमें इसका डुअल लिखना है. अभी तक जो हमने कंडीशंस बताई, नॉन नेगेटिविटी कंडीशंस कम क्लियर हो रही है. अब आप देखिए, दिस इज मिनिमाइजेशन केस, तो हमारी सारी इनइक्वालिटीज ग्रेटर देन और इक्वल टू टाइप की होनी चाहिए. लेकिन थर्ड इक्वालिटी हमारी लेस देन और इक्वल टू टाइप की है. कोई वेरिएबल अनरिस्ट्रिक्टेड इनसाइन नहीं, इक्वेशंस नहीं है. तो सबसे पहले हमें क्या करना होगा, दिस इनइक्वालिटी हैज टू बी कन्वर्टेड इनटू डिजायर्ड वन दैट इज ग्रेटर देन और इक्वल टू टाइप. तो उसके लिए हम क्या करेंगे, -1 से दोनों तरफ हम मल्टीप्लाई कर देंगे. अगर हम यहां पर भी मल्टीप्लाई कर देंगे और -1 से यहाँ पर भी हम अगर मल्टीप्लाई कर देंगे दोनों तरफ, तो ये इनइक्वालिटी कन्वर्ट हो जाएगी. और उसको हम दोबारा लिखते हैं. सो हियर मिनिमम z इज इक्वल टू 10x1 प्लस 20x2 हियर सब्जेक्ट टू कॉन्स्ट्रेंट्स 3x1 प्लस 2x2 इज लेस देन और ग्रेटर देन और इक्वल टू 18, x1 प्लस 3x2 ग्रेटर देन और इक्वल टू 8, और हम इधर फिर माइनस से करेंगे. सो -2x1 प्लस x2 इज ग्रेटर देन और इक्वल टू -6, एंड x1 x2 ग्रेटर देन और इक्वल टू 0। ये जैसे कि जैसे माइनस से मल्टीप्लाई करते हैं ये साइन अपने आप चेंज हो जाता है। अगर आपको ना समझ में आया हो तो इसको हम दोबारा करके बताते हैं। जैसे मान लीजिए अगर हम लिखते हैं दैट 10 इज ग्रेटर देन और इक्वल टू 5, दिस एवरीबडी विल एक्सेप्ट इट, राइट। 10 5 से बड़ा है, बराबर तो नहीं है। अब अगर हम दोनों तरफ माइनस से मल्टीप्लाई कर दें -5, अब आप यहां पर देखें -10 नाउ इज लेस देन -5। -10 की वैल्यू -5 से कम हो गई। यहां पर +10 की वैल्यू 5 से ज्यादा है तो ग्रेटर देन, और जैसे हमने माइनस साइन से दोनों तरफ से मल्टीप्लाई किया तो ये लेस देन हो गया। तो इसीलिए कहते हैं कि जैसे हम माइनस साइन से दोनों तरफ से मल्टीप्लाई कर देंगे इनइक्वालिटी का साइन अपने आप चेंज हो जाएगा एंड देन वी विल हैव डिजायर्ड इनइक्वालिटी। अब हम यहां से देखते हैं ये हमारा प्राइमल है एंड नाउ दिस इज स्टैंडर्ड फॉर्म ऑफ प्राइमल। मिनिमम जेड है, सारी इनइक्वालिटी ग्रेटर देन और इक्वल टू 10 की। अब हम जरा यहां पर ध्यान देते हैं। अब देखिए इसका हम डुअल लिखते हैं, मिनिमम का हमारा मैक्सिमम हो जाएगा, जेड को हम जी से लिखेंगे एंड हियर इट इज सी एक्स सी का वाई बी डैश। व्हाट इज बी डैश? तो यहां पर बी क्या है? बी इज बेसिकली दिस इज बी, हियर 18 8 -6 दिस इज बी। सो बी वाज the column matrix of RHS values and so here they are 3, so here we will write 18। now ये जो B column matrix है ये रो इसका ट्रांसपोज होगा B डैश, so that is 18y1 plus 8y2 minus 6y3 subject to constraints। अब यहां पर जो हमारा मैट्रिक्स है A, दैट इज 3 2 लाइक दैट, तो ये जो कॉलम है ये रो हो जाएगा। सो हियर 3y1 प्लस y2 माइनस 2y3 इज लेस देन और इक्वल टू फर्स्ट दैट इज C डैश, सो हियर 10 एंड 2y1 plus 3y2 plus y3 is less than or equal to 20 and y1 y2 y3 greater than or equal to 0. So this is the dual, this was the primal and now this is the dual। तो आप देखिए कितने इजी तरीके से आपको हमें लगता है समझ में आ गया होगा दैट हमने बी मैट्रिक्स के फॉर्म में था, इसको हम ऑब्जेक्टिव फंक्शन में ले गए, रो मैट्रिक्स के फॉर्म में था, कॉलम में थे, और इस तरीके से हमने डुअल लिख लिया। अब हम इस पर फिर सिंपलेस्ट मेथड अप्लाई करके अगर सेंसिटिविटी एनालिसिस देखना चाहें कि क्या चेंजेस वेरिएबल्स में आते हैं दैट वी कैन डू। सो दैट्स हाउ हमारी कोशिश रही कि आपको हम प्राइमल से डुअल लिखना बताएं और इसी तरीके से हम कर सकते हैं। और भी हम कुछ स्पेशल प्रॉब्लम्स आगे के वीडियोस में लेंगे। सो आई होप दैट यू हैव लाइक्ड इट, और अगर आपको पसंद आया है तो आप हमारा ये ज़रूर लाइक करें, सब्सक्राइब करें। और इसके पहले मैं आपको बता दूं कि अगर आपको कोई भी क्वेरीज है तो आप हमें हमारे ईमेल आईडी पर rclasses@gmail.com पर आप अपनी क्वेरी हमें लिख सकते हैं। Thank you very much. Have a nice time. Thank you.